This morning we have sort of a unique event going on. We're going to have a reboost where we're going to fire the engines on the aft end of the space station to increase our velocity in orbit around the Earth about 1 meter per second or so. So not a lot, but enough to raise our orbit a little bit and to prepare for a coming Progress supply ship as well as the space shuttle shortly after that. Now, some of you have asked why we need to do a reboost. Do we stay in orbit? And questions like that. The answer is there is a small amount of drag here, even 200 miles above the Earth. And they say it's from atomic oxygen. So there's a very small amount of oxygen present out there in the vacuum of space. And so it's not 100% vacuum. And that those atoms cause a finite amount of drag on the space station. So over a period of time, we slow down and our altitude over the Earth decreases. So due to that, and also due to the requirements of rendezvous of spacecraft like Progress and Shuttle, we need to adjust the orbit, usually increase it periodically. And we're going to do that this morning. I'm going to try to give a demonstration while it's happening so that you can see the acceleration from the engines. So let's head down to the Russian segment and prepare for that. Okay, here we are down in the Russian segment in the service module, and we don't actually operate the reboost here on board. The ground programs it, and then the computers on board execute the reboost. But we have insight into the parameters coming up, and it looks like we're programmed to do a 2.7 meter per second increase in our delta V. When the engines fire, we will experience a small acceleration, not a whole lot, but it will be 0.0185 meters per second squared. And I'm going to try to demonstrate that at the time of ignition and during the burn. Now, the way I'm going to demonstrate the acceleration that comes during the reboost is by using this camera. 800 millimeter lens, so it's pretty massive actually. And you can see I can float it here, and there's no reboost going on right now, so the camera's not going to go anywhere. It's just going to slowly drift due to the ventilation, or if I put any velocity into it, it'll drift out of the scene. But I'm going to try to hold it here steady, and you can see that it stays very steady. That's going to be different at the point of ignition and during the reboost, and we'll see that here in a few minutes. Okay, we have about 40 seconds or so before the burn starts. Again, we're in weightlessness right now, and there's no accelerations, virtually no accelerations on us, and you can see I'm floating this camera right here, and it's not going anywhere. That's going to change here in just a little while. Let's see. Looks like we have about 20 seconds to go until the scheduled burn time. There's my camera. I'm setting it up for ignition. There it goes. It actually came a little bit early. Now watch the camera accelerate toward you. There it goes. I'm going to reach out and grab it and bring it back in the view here. And I'm holding it. I'm actually feeling the acceleration. I'm going to let go again. And here it goes. It's going to take off. I'll try not to let it hit you. Just going to miss you.
Here we are at the International Space Station. We're doing a reboost right now, and we're showing that the space station is actually accelerating away from us, because we're going to float in the middle of the cabin, and it started already. We start off stopped in front of the camera,
and you can see,
and we get moved. The space station's accelerating, leaving us behind.
Yeah, that's yeah. Wow. 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 Ooh. That's amazing. I'll do it again. Okay. Second. Floating still. It's really cute. Wow.